Okay, so thank you, Martin. So I will be talking today about deployment. I will divide the presentation in 3 parts. And I hope that after this presentation, we understand that R is very good for machine learning. And that what is important to be successful, that this is approach. So I start with what is effective data science process, because I hope there are a lot of data scientists here listening to me. So effective data science process composed of 3 aspects. You have people, this means we have knowledge, we have experience. You have processes, and you have a technology. Combination of those 3 parts is like that people should know what to do. They should follow processes that they can control what will happen next, and they should use tools to support the processes. So as I said to Marcin before presentation, if you use tool and you don't know why, you don't support process with your tool, you are just using the tool because of hype. So this is what I call effective data science process. And this is important to understand when you think about deployment, that all 3 aspects must be in complete sync. Out of 3 parts that all of you have, this is knowledge, this is process, and those are tools. I say that having a process is the most important to be successful in delivering anything to business. And I like CRISP, although I don't use it as a book version. I adapted this. But I think that any one of you could use any business process or any methodology for data science you would like to have. For example, there is Microsoft Team Data Science process, very similar. But the message is that just use any of them, learn this, try to do this, repeat, and when you do this 3 times, automate. Automate anything that you want. You will find that takes you too much time. So this is the beginning of CRISP-DM. And when you think about CRISP-DM and you read the books about this, you start with business and data understanding. I have taken the most important parts I always try to ask. And, this is the first step when you think about deployment. So anytime I deliver machine learning project, at the very first beginning, I ask myself, how do I deploy? And the question, what is the business case for a model? This is a question to a business. If the business cannot answer this question, this means that you will not deploy. So what is important from the business perspective? Important is timeline. You need to understand to a very precise time points, when and how the model is being used, how the recommendations from the models are being consumed, and how and when do you get the feedback. If you cannot draw this timeline, probably you will not be able to implement this as a software. So this is very important when we deliver, and me and my team, I ask them to be able to answer exactly these questions. And timeline is important because if you don't understand timeline, you can have data leakage. So the message is that you start deployment here. And the second, if there is no business value, you just finish the project. And this is my policy. So this means that if business cannot justify the value, they think they would benefit from cooperation with you, this is just a kind of academia work, which, I don't say anything bad about academia, but This is not business. So this is an introduction. And now I would like to switch to a second part, which is about R as a language. And I asked my friend, who is a software engineer, to help me think about R as language, how he would approach. And by the way, we use this approach in our practice. Not think about R as a language for data science, just as a language like Java. So what's this view? So many of you, this is my experience, use R for POCs or R&D processes that in fact have no deployment phase. And the difference for you to understand what I'm talking about is that I'm talking about something that will work in a longer term. This is not generating a report. This is embedding a model in a business process that is being continued for a, call it, infinity. So this is important because if you don't understand this, you will not understand the speech. This is production-ready setup that we find for R as working and proved. So one thing you have on the slide is that there are separate dev and production environments. So this means that you have to solve transfer from dev to production, and to use this and to solve this problem, you use different tools. And by the way, those tools, except local cron, are used by the software companies, and also this tool. But important thing is that here you can change, here you cannot. So you must think in a way how each change here, each line of code here can be run in an environment that you cannot control, I mean directly. And this mind of thinking is really important to understand how to be successful with deployment. So in this environment, when you develop a software, you need to be able to create a new software, and also on production, if there is a bug or you miss a functionality, you need to be able to take the solution from the production, update it, and again, put it back on production. And this is really important not to forget about reproducibility, especially with machine learning and recommendations you generate, that you are able to track back in time, understand why you sent credit scoring to this customer at this level. So when you think about moving from development to production, you are thinking about releases. And to prepare from release, you need to be able to understand when you are ready for upgrade or when you are ready for support. And this is exactly this slide could be, for Java, for Python, whatever language you want to have. And so to conclude about this part, moving from development to production, is that, this is just any software solution. R is not scripting language. R is just a language, programming language. This is still incomplete language, and you can build big solutions there. So you should use, as for any other language, the guidelines that software the developers created, and I will go through some guidelines. So when you think about this slide, you have a version control. So I will tell you why do you need version control and for what. So version control is solving collaboration problem, and in this collaboration problem, this is solving emerging problem. So if two persons edit the same file, there is a question how to merge the different changes. So you have the only one version of the file, and this is why you use version control for software development, because many developers edit or can edit the same software text file. Then the second thing, what has changed, and you can track the changes. You can understand, of course, if you write proper messages. What was the change introduced by a colleague? And then, of course, you can track back. So if you have implemented your solution today and after 6 months you want to solve the bug, you can track back, get the sources from this day and change them to remove the bug. So version control is collaboration and merging problem. This is not for data storage. On market, we have 2 kinds of version control. I don't know how many of you are aware of when you are using Git, then in fact it's overkill for you. So the very simple, so the basic or the previous version control was SVN, and this will work like on the left slide, so centralized version control, and this was very easy because you just copied the version, changed it, and put this exactly at the same moment on the server. With Git, you copy the whole repository, you can commit here, and you push to the common repository, which in most cases doesn't give any big advantage, although sometimes it's easier to use it. But you should be aware that using Git now is not because of functionality, it's because of GitHub. So this is version control. Second thing, when you think about the whole concept, R doesn't have standardized project. So, for example, if you use RStudio, there is a concept of project, which means a folder. So if you press project.prj file, it makes RStudio open session in this folder where this file is located. But in fact, when you think about other languages, project is something more. Project compose, and I try to make it in 3 bullets, from 3 parts. So one part are master scripts. So if you ever programmed with Java or C++, there is main function. And this is very nice design pattern. With Python, you can have also this main part for running your software. With R, you can also have like this. So master file or master script is for running your application. This is high-level flow control. When you want to implement logic of the project, you use local packages, and they help you to combat with complexity. So, 15 years ago, we used a lot of R sources, and we source them to other files. Now, for each project, we build a lot of packages, very small packages with very well-defined set of functionality, and they are local to the project. No one wants to see them in a cron or another place. And then you have dependencies. And dependencies is functionality that comes to you from third parties. So, for example, if you in your project would like to use dplyr, you put dplyr as a dependency of your whole project. And when you think about deploying R, you should think about deploying the whole project, not only one script or one package, because this is the whole application. When you think about or read about Java or open a Java IDE or Python, they have very similar structure. Of course, everyone can have structure they like, but what is important to understand here, that you have project that is integral. And what is important next, you should manage the project as a whole. And this is nice because when you standardize this, it's much easier to learn new employee or a new colleague. It's much easier to automate testing, building packages, and all the stuff. And it's much easier to deploy because you can define what does it mean that you build a package from a project, deployment package from a project. And the last, which is also important, when you collaborate with different people, you should agree on best practices. so that you avoid a situation that one of your colleagues starts working with completely different practices that are not of your standard. Okay, so what about dependency management? So when you have project and it depends on external packages, you should understand that changing a version of package is can completely break your project. And you know what is typical when you use install packages, which is, I think, from my opinion, should be forbidden in R, using this as a direct, it's spoiling the project. So this problem comes from the system-wide packages. So the solution is to have project-based packages. And of course, you have to understand that saying that you only need dplyr is not enough. You should say that I have used dplyr in this version or data table in this version, and also other dependencies that goes with this version of the main package that you want to use. So how do we solve this, and how do we recommend solving this? For each project, install packages in a project folder. So this means that packages that you install for one project and the other project don't interfere to each other. This is important when you handle different projects and you want to be able to deploy, because you have everything here. And with R, this is very nice because you can just zip this and send to production. Okay, so what's next? Installing the packages in a project folder is not enough, because if you want to reproduce, so you want to repeat this procedure after 6 months, you should be able to get the source packages from the external repositories. And if you just install from cron, you are doomed, because cron is changing very fast. So the packages goes and change their versions. So for example, after 6 months, probably will not be able to install the packages here. So the second thing that you could use is use mrun. By the way, mrun is very unstable, and I have noticed stability of mrun for many years, and now I recommend having local cron for this. The second thing is packages on GitHub. They are very popular now, more and more popular, which is, I always say, it is very bad for R. I mean, keeping them on cron on GitHub is bad. Developing on GitHub is very good, because there is a lot of testing around and people are testing the packages. But if you install packages from GitHub, very often you have to compile them, and there is no easy way to control version. So what software engineer does if they deal with cron versions of libraries, they either download exact version and keep this in a local source code, or keep some points to cron. But what I recommend, put this package in in-house package repository, what is called local cron. So you don't have to deal with any GitHub. You know, companies collapse, so probably GitHub one day can collapse as well. So you will have this package. You can have this package in a source version and in the binary version, doesn't matter, but download this. Okay. The next thing, testing. If you have a project comparing to just a package or a script, you can do much more testing. So first testing is unit testing. Oh, sorry. And unit testing is for single functionality. So if you have a package inside your project, you can test this. But if you have just packages, it will be very difficult to make integration tests. So having a project, you can make integration tests as testing the project as a whole functionality, which can be quite complex. The last thing, when you want to deploy, you have to plan performance loss or stress tests, and they are, in my opinion, mostly manual. So I didn't find this as ability to automate. The first two you can automate. So having project structure, you can do much more testing. So your solution is much more robust. and testing each package separately doesn't mean that they work together properly, because you miss this. All right, so the last thing is continuous integration, continuous delivery. This slide shows the difference. So what about this? Do you know Travis, probably Travis CI when you use GitHub? So this is this part. So what this tool does, it takes the source code from the repository, builds the solution. It can compile, it can build packages, it can prepare everything. Then it can run tests, and then it can test deployment. And this thing is done on in a complete raw environment comparing to your development environment. So it can check if you forget something when developing a software. This is very good when you want to be robust deploying your solutions. And continuous delivery is the situation that after testing deployment went well, you do integration test, so the whole solution is ready for deployment, and then just deploy it. What it means, very often when we deploy our solution, we just deliver zip file to a production server and just unzip this. And what is important with those tools, that they automate what is very tedious and error prone. So a lot of errors happen when you try to deploy by manual operation. And with those tools, when you know that you will not intervene with your hands in this process, you have to really make this process robust. Regarding the tools, there are a lot of them, but the concept is very similar, and you have the concept on the slide. So you have a project, you have a configuration of a project in a tool that contains some build steps. The steps are executed one after each other, they depend on each other, and then each step generates artifacts. So in fact, Jenkins or this kind of tools just run some external tools and collect artifacts and check if the tools told them that it went well or not. So the concept is really nice, simple, but it's very powerful. Okay, so we are something in the middle, and I'm in the middle. So what I told you before is how R is perceived by a software engineer. So if you write any software in R, you want to deploy it, you can follow all the steps. But what if you want to use R for machine learning and want to be robust also here? And this needs to update what software engineers understand, because software engineers doesn't understand machine learning. So we need to add some special concepts to make deployment of not only software, but also machine learning models. All right, so when you think about machine learning and you think about setup for production machine learning, this is what we created as a instance of how we would implement our concept. So on the slide, you have development environment. This is where you run RStudio or any other editor. You have a production environment. This is where your models are being run. This means you feed the models, you score the models. You can also run some ETLs. Most important thing to understand, you go there directly. You play only here. What else you need to have? You have feature store. I will tell more about this, which is your data access, and you keep your packages, and of course you use Jenkins and Git for source management and deployment. So this setup I will go through. In my opinion, and it was tested with market, it fits perfectly for large-scale machine learning applications, and you can implement this with R as well. Okay, so going back to the process, when you did business and data understanding, so you have proof from the business that there is a business value and you have some data that probably could help you deliver this business value, you go to a development phase, model development phase. And as I said, when you want to be robust and you want to develop and deliver a model, you start with building a first model. So assuming you have a data, if not, the model is just a mean. So this is also a model. So you build the first model, analyze its performance. If it's not good enough, you add some transformation to your features or features as well, update the model and get back to analyzing performance. If the performance is okay, you stop the process. I know there is a lot about exploratory data analysis, notebooks, and all stuff. I say one thing: if you deliver a model, do EDA around the model. Don't build the model counting means and printing tables. Printing a table with means per group is a model. So why not build a model from the scratch here? And when you think about model development process like this, you can optimize this in the following ways. So first, to be robust, you have to have a lot of transformations in your library. Second, you have to be able to run experiments. This means you have to implement some functionality that you can test this circle in an automatic way. So, you know, upfront, not knowing the problem, you can just define, okay, so I will use this transformation and this kind of algorithm and let the computer calculate everything for me. So the computer can do this. The next thing is consider AutoML. Have you ever, any one of you, tried to use an AutoML solution? Open source or commercial? Okay, so open source is great, of course, but I think commercial AutoMLs will be much stronger. But why consider AutoML for initial model? We are in a business process. If we know that business sees the value in solving the business problem, answering fast, this means after first model that there is possibility to solve the problem with some quality, is very nice, because after one day you can get the very fast result to the business and you can solve next 3 models. Not doing, 15 years ago when I built a model, I did it by hand, solving set of equations. Now I just prepare some data sets, put into an AutoML and get some result. If the result is fine, I'm done with the process. I can go to another model. If it's not fine, I can think why. So I analyze performance, maybe tweak something, maybe add new data set, and also use this part. So this is very nice, thinking about this. And by the way, having your own AutoML is not the big difficult issue with R, because R is great for DSL. So you can build your own language and your own libraries for this. But what is very important, and what I did wrong many years ago, is that after this phase of developing the model, I had to do another project to implement the model on production. So now you should do this using abstraction, that there is no extra coding. So after this engine is working, it should generate artifacts that can just be run on production for scoring or training. This is really important. Okay, so development phase from the setup point of view, architecture point of view, takes into account those components. So you take a data, build a model, take some packages, and deal with Git sources. Okay, so when you think about going deployment, the different components are being used. So first, Jenkins takes your sources from Git, you take packages from local CRAN or external CRAN as well, it can be, and in an automatic way builds a deployment package and puts it on a specific component. And when the components are filled with a new version, we are in production, those components are working. So we use Jenkins for steering the workflow. So we say that your model should score every Monday or should be retrained every first day of month. And the components model factory scoring engine takes data from feature store and does the computation. So this is how those components work together. And now I will go more about the components themselves. But what is important message from this part is that you should think in a way that when you are done with evaluation, this arrow from evaluation to deployment is without any coding. So I will tell you a story that I had about 15 years ago. We had a solution for energy forecasting. Solution was in two parts. One was C++ application with plots visualization and model management. And I have implemented model as RScripts. So the process was that I developed models, those three points using CSV files. And after a while, either I got good models or I ran out of time. I said I had good enough models. I wanted to deploy. And when I wanted to deploy, I had to adapt with my scripts to requirements of the application. And it required another project. And it was error prone and it didn't work, in fact. So now we wanted to remove this coding here. All right. Now I will go through concept and abstractions that are important, that your whole setup is working properly. So there are 4, 5, okay, but ETL executor is very primitive. So there are 1, 2, 3, 4 important components. Feature store, model factory, model repository, and scoring engine. So when you want to go with machine learning, you should have those components somehow defined. This can be, set of packages, this can be set of application, I don't care. But somehow you should have this in your environment. So what is feature store design pattern? Feature store design pattern was created to make analytical part independent from the physical representation of the data. And this is a very, very important part of the solution. So here you have a data sources. This can be, data warehouse. This can be a CSV files. I don't care. If there are CSV files, you should ask how they are being delivered. Then you generate all the business logic here and load this repository. This repository composed of objects that you model, and each of those objects have attributes. So ETLs here populate attributes of objects that then you can get from feature store using very high-level abstraction. What is important here that I don't use here any business logic and I don't use any SQL, I don't use any read CSV instructions. Why? Because they are not reproducible and they are putting you too much to the data representation. So, in fact, when you try to prepare data sets for your models, you don't join here explicitly. This is done implicitly by a feature store. And this is a very good practice if you, for example, get a data set as a CSV files, but on production you will use database that you implement feature store and have two interfaces, one for CSV, one for DB, and this part is independent. So when you are developing a model, you use CSV file loading functions, build a model, and when you go on production on DB, you just replace these loading functions to a DB loading function. But your machine learning code is not changed. So this is important because when you think about features as just columns in a tables, you are reducing a lot of benefits. Think about features as first-class objects. So what I think about here is that I have objects and attributes that are joined in a data model, and when I ask feature store to get a new table, it just does the joins for me, and I don't care how it's implemented inside. When you think about software engineering, they have object relational mapper design pattern, which is very similar to what is presented here. So if you ask your colleagues that are software engineers, do you write SQL code in your application? They will tell you, no, we don't. We use ORM. So data engineers, data scientists, sorry, shouldn't also use SQL when they try to build a model. They should use SQL, they can, for writing ETLs, of course. The second part is model factor and scoring engine design pattern. And this is nice because not obvious thing is that when you have a data table, data frame in a session, and you change a column, at this very moment, when you change the column, like, you know, applying a logarithm to a column, you are not able to deploy this code unless you pack this feature transformation in a package, because of two things. Because of this, that feature transformation during model building must be repeated during model scoring. So either you repeat the code, these changing columns, in two places, or you somehow make an object of feature transformation. And this pattern is very powerful. If you think about Caret or MLR or new tidy models solutions, they are working like this. So they have separate objects for feature transformations that generate new tables with transformed columns, and then you can save those objects. So you don't repeat the code, you just use one object and keep it for model scoring, model building, and this is the same. And also, as I said, please remember one thing. Oh, I didn't tell you, but feature transformation is part of model building. So, sorry, I've seen architectures in big enterprises where there were columns with logarithms, so with already transformed features. This is completely bad approach. Why? Because in feature store you should have information that is understood by business. So if you take a logarithm of a column, probably it's because you want to have a better model. And because of that, this should be part of the model building. And the last point, consider using AutoML pattern as well, because it simplifies everything. So the commercial AutoMLs does feature transformation for you. So this can be only one box. Next is model repository. And model repository is very simple. By the way, we don't use Git for this, because Git is not very good for storing binary objects. But you know, file system is very great for this. So you have a model, and after you run models, it generates model instances. And this kind of hierarchical structure can be accessed by model scoring part. And if you want to learn more about software engineering patterns, you can read about Artifactory pattern. By the way, there is a solution called Artifactory, but this solution says, okay, we have a repository of any binary object you want to have, and you can versionize this. So you can get to each particular version of your model. And this is very important to have the model versionized, because someone can ask you to tell you what was the model that generated those scores. Not the code that built the model, but exact model object. All right, so I have 5 minutes, so I will summarize the talk. So when I think about this policy, it's that the deployment, and this is a state of mind. When you start a project, you always deploying. So you should talk to the business in such a way that you are able to deploy, that you will have a plan how the final solution will run after you implement this. The second thing is that R is like another programming language. So when you go to your IT department or your IT colleague or software engineer colleague, tell them that this is just a regular programming language, and they can help you using any software engineering tools for deployment. And the last thing, when you think about deploying machine learning models, you have to control other parts of the solution, and you have to go a bit deeper to be able to deploy the models using some abstractions that I mentioned before. So we have 3 minutes. Please ask me questions.